Welcome, ladies and gentlemen. So what I'd like to do is kind of talk to you a little bit about, what exactly is M behavior. And, basically M behavior is a way for us to be able to identify where our graphs are going to kind of go and end up. So if, we look at a Cartesian coordinate system here, when we have a graph, especially a continuous graph, meaning that the graph is going to continue on and on and on and on to forever. Well, we know that this Cartesian graph, the reason why I wrote these arrows is because this x and y, this continues to infinity, continues to negative infinity, continues up to infinity, and continues down to negative infinity. So when we're talking about, graphs, especially when I only draw, for instance, like when I graph a parabola and a graph, looks like this. Well, remember, this graph is going to continue going up and going out, right? It's going to continue going to the right towards infinity. It's going to continue going up into infinity. So M behavior is a way for us to kind of describe where the graph is going to go, because we can see what the graph is doing now. But if we were to maybe expand, and like zoom out, what is the graph going to keep on doing? And this graph, this graph is going to keep on rising to the right. And it's also going to keep on rising to the left. But that can also change, and for a quadratic, it's pretty simple. We have y equals, x squared. But what's nice about the M behavior is, you don't have to know exactly what the graph's going to look like. What if I had y equals 8x to the 16th power? Guess what? This M behavior is going to be exactly the same, because using the leading coefficient test, my coefficient is both positive and my degrees are both even. So therefore, I know that my graph is going to rise to the left and it's going to rise to the right. What it does all in here is really not a significance when determining M behavior, because we know that the M behavior is going to be the same for all polynomials that are even and have a leading coefficient that is positive. The same thing for all polynomials that are even with the leading coefficient is negative. So the leading coefficient test allows us to kind of determine what the M behavior of is a polynomial without having any idea what the graph is going to look like, but just by applying the leading coefficient test. And we can be able to determine then where the graph is going to continue as it keeps on expanding. So there you go, ladies and gentlemen. That is just kind of an overview summary of what exactly is M behavior. Thanks.